say for example, write this as limit x goes to 0 plus, say, log x by, say, 1 over x. Let's write it in this manner. So if you're going to substitute log 0, for example, so this would be infinity, and 1 over 0, so this would be infinity as well. So infinity by infinity form. You got it in indeterminate form. And now differentiate it. Apply the L'Hopital rule. X goes to 0 plus is going to be 1 over x, and the derivative of the 1 over x is going to be minus 1 over x square. And if you simplify this, this is going to be limit x goes to 0 plus minus x square upon x. So minus x square upon x will become limit x goes to 0 plus minus x, and if you substitute the limit you get a 0. So this limit is 0. So you have to change the denominator, and then you can also have okay. So if you have 0 by infinity form, then try to convert it into either 0 by 0 form or infinity by infinity form, and then apply the L'Hopital rule. Okay. Maybe we'll discuss some more indeterminate forms. So we have so far discussed 0 by 0, 0 by infinity, infinity by infinity, 0 multiplied by infinity. You can have this. Now imagine you have a situation where you have limit x goes to a f of x, and that's infinity, and you have limit x goes to a g of x, that is infinity too. And I want to say compute limit x goes to a f of x minus g of x, or plus g of x, doesn't matter. Then what would be this form? So this form would be infinity minus infinity. Okay? So infinity minus infinity is also an indeterminate form actually. You're going to call that also an indeterminate form. Okay? So if you have this form, infinity by infinity, this is fourth form of infinity, infinity minus infinity in determinant form. Why? You can't say infinity minus infinity is 0. You can't say that actually. Okay. You might say infinity plus infinity is infinity. You can't say infinity minus infinity is 0. Okay. So infinity plus infinity is infinity. But infinity minus infinity, you can't say 0 actually. And you can't even say infinity minus infinity is infinity. So we don't know about the sizes of the infinity. So what to do in this situation? Again, if you have this determinant form, try to convert it into 0 by 0 or infinity by infinity form, and then apply the L'Hopital rule. So for example, an example in this case is that imagine you want to compute, say, limit x goes to, say, pi by 2 from the left, and I have secant x minus tangent x. Okay. Now what is secant pi by 2? Okay. Secant pi by 2. You'll see that secant pi by 2 is infinity. Tangent pi by 2 also infinity, so it's infinity minus infinity form. The question is, can we do something with it? The answer is that yes, we can do one thing. For example, so one way could be that, okay, substitute the values of secant and tangent actually, so maybe we get a better result. So can I have 1 over cos x minus sine x over cos x. So you're going to get what? Limit x goes to pi by 2 from the negative is going to be cos x sine 1 minus sine x. Okay. Now, as x goes to pi by 2, sine pi by 2 is 1, so 1 minus 1, 0, and cos pi by 2 is 0, so this is again a 0 by 0 form, but better than infinity by infinity, because now I can apply what do you call my L'Hopital rule. So if I apply the L'Hopital rule, this limit will become limit x goes to minus pi by 2, so 1 minus sine x will become 0 minus cos x, and cos x will become minus sine x. And now if we substitute, for example, limit, so this will become cos pi by 2 and this will become sine pi by 2. Now cos pi by 2 is 0 and sine pi by 2 is 1. So it's going to be 0 by 1, so this is equal to 0, so you got the limit actually. Okay. So again, the key trick is try to convert your indeterminate form into 0 by 0 or infinity by infinity form. Obviously, first you need to determine what are the indeterminate forms actually. So 0 by 0 is indeterminate form, infinity by infinity is indeterminate form, 0 multiplied by infinity is indeterminate form, infinity minus infinity is indeterminate form. So this is the fourth one actually. And now I would like to move towards some more indeterminate forms actually. And maybe a list some actually. By the way, 0 power 0 is indeterminate form, so the total all indeterminate forms. Okay, so let's, what could be the potential indeterminate forms actually. So 0 by 0 is indeterminate form. You need to apply L'Hopital rule. Infinity by infinity is indeterminate form. 0 multiplied by infinity is indeterminate form. Infinity minus infinity is indeterminate form. 0 power 0 is indeterminate form. Okay. 0 power infinity is indeterminate form. Okay. Infinity power 0 is also indeterminate form. So what do you mean by infinity power 0? Okay. And some constant, for example, power infinity is indeterminate form. So these are some of the more indeterminate forms actually. 0 power infinity is not indeterminate. Okay, infinity power 0 and 1 power infinity, 0 power 0, these are the indeterminate form. What was the trick to solve the problem? For example, in these indeterminate form, try to convert such a form into these forms. This form into one of these forms and then apply L'Hopital rule. The same is the case would be true here actually. So imagine if you have a 0 by 0 form, indeterminacy, try to convert it into 0 by 0 or infinity by infinity form. If you have infinity power 0 type form, try to convert it into the infinity by infinity form or 1 power infinity form. In these three indeterminate forms, the trick is taking log will help actually. Taking log will help you to convert these forms into these two forms and then apply L'Hopital rule. For example, let me do one example for you. Say I have to calculate limit x goes to 0 plus 1 plus 4 sine x power say cot x actually. Okay, seems a complicated form. So if you say, for example, substitute this, so what is limit say x goes to 0 plus say 1 plus 4 sine x. Okay, this is going to be equal to, if you're going to substitute say sine 0, so this is going to be 1. What is say limit x goes to 0 plus say cot x? Cot x, now the cot is cos by sine, so taking the limit would give you 0 upon 1 upon 0, so this would give you infinity. So this is a form of 1 power infinity. 1 power infinity. 1 power infinity. So how to deal with such kind of situation? So the trick to deal with such kind of situation is that give first of all that function a name. So take say 1 plus 4 sine x and give it a power say cot x and give it a name say y, and take the log onto the both sides. So if I take the log y, okay, so you're going to get what? You're going to get log of 1 plus 4 sine x power cot. But we can bring this power in the constant, so cot x times log of 1 plus 4 sine x. Okay, this is what that you're going to get. Now see what you get if you take, for example, limit x goes to 0. So if I'm taking limit x goes to 0, so this will become infinity. Log of 1 plus 0, this is going to be log 1. So now the form is 0 multiplied by infinity. So we converted our infinity by infinity form into the 0 multiplied by infinity form actually. And how we were converting 0 multiplied by infinity form into the infinity or infinity by infinity form? By taking one of the factors into the denominator. So in other words, if you have say f of x times g of x, try to write it in this form, f of x divided by 1 over g of x actually. Okay, and compute the limit. So what should I do? So on this, say for example, I can take limit x goes to 0 plus. On this side I have log y. On this side, limit x goes to 0 plus. I can do what? I can for example do this. Log of say 1 plus 4 sine x divided by 1 upon cot x. 1 upon cot x. Okay, so you're going to get 1 upon cot x. Now if you see what you get, so if you substitute limit here, this will become 0, and 1 upon cot, 1 over infinity, so this will become also 0. So this is now in 0 by 0 form. Okay. By the way, I can simplify it a bit step more. Limit x goes to 0 plus log of say 1 plus 4 sine x. 1 upon cot x can be written as the tangent x. So still, you substitute 0 here, so log of 1, 0. Tangent to 0 is also 0 actually, so 0 by 0 form. And now apply what do you call the L'Hopital rule. So if you can apply the L'Hopital rule, limit x goes to 0 plus. So it's going to be 1 over 1 plus 4 sine x times the derivative of 1 plus 4 sine x. So it's going to be 0 plus 4 cosine x actually. This is what that you're going to get. Divided by tangent x. What is the derivative of the tangent x? So the derivative of the tangent x is secant square x actually. So this is what that you're going to get. Okay, secant square x. And now if you substitute the limit, what you're going to get? So if you substitute the limit 4 cos x, so 4 times cos 0 divided by, so if I substitute limit, so you're going to get now 4 cos 0 divided by 1 plus 4 sine 0 and divided by secant square 0. Secant 0 is 1 over cos 0 means 1. So this will become 4 times 1 divided by 1 plus 0, 1 divided by 1. So everything is equal to 4, so you got the limit. But you are not done yet. So you have to take care of a last bit. And what is that last bit? That last bit is that keep in view on other side you have limit x goes to 0, log of y equal to, we computed it before actually. We were not interested in limit x goes to 0 log y, but we are interested in limit x goes to 0 y actually. So how can I turn this equation in the terms of the y actually? So what you can do, take the anti-log. So if you take the anti-log, limit x goes to 0 plus, so e to the log y will become y, and you're going to get e to the 4. And if you substitute the limit, so you're going to get limit x goes to 0, or substitute the value of the y for 1 plus 4 sine x power, what do you call, cot x equal to e to the 4 actually. So this would be the limit actually. So we computed the complicated limit. So the way was this, I gave the function name, so it is like 0 by infinity form. I gave the function name, took log, wrote it in a different form, taking the limit, the different form is like 0 by infinity form, then try to wrote it into 0 by 0 form, applied L'Hopital rule, substituted limit, and I got this number. So once you get this number is not your answer. Why? Because on other side you have this limit x goes to 0 plus log y. In other words, what you have computed, what you have shown is that limit x goes to 0 plus log y is equal to 4. While you need the limit for the y. So what you always have to do, take the anti-log. So you're going to take the anti-log, so this will become y and this will become e power 4. And hence, y is your original function, so you got the limit for your original function actually. Okay. You got the limit for your original function. Let me do another example. Short example in which the same trick would work. So this trick would work 0 power 0, 0 power infinity power 0, 1 power infinity, in all these forms actually. So for example, you have limit x goes to 0 and you want to compute x power x actually. Now if you see, this is like 0 power 0 form actually. Okay. So what would be the trick to do? Take this x power x, give it a name y. Take log y is going to be log x power x, and this will be equal to x log x. And in this, take limit x goes to 0. Log y limit x goes to 0. So then you're going to have x goes to 0. This would be a new form. So 0 multiplied by log 0. So this is like a 0 by infinity form. And how to deal with the 0 by infinity form? Okay, so we saw it actually that you can do in this manner. Limit x goes to 0. Say for example you write log x divided by 1 over x. So you have the same expression. So we computed this limit before actually. So again, if you apply for example the L'Hopital rule, so the application of L'Hopital rule would give you what? It would give you limit x goes to 0, log x will become 1 over x, and this will become minus 1 over x square actually. And if you simplify this, so this will become limit x goes to 0 minus x, so this is equal to 0. Hence, this is not our required limit. What we computed limit x goes to 0, x power log y equal to 0. So this is what that you get. And we want the limit for the y, not log y. So what you can do, take the exponential, take the anti-log. So if you're going to take the anti-log, limit x goes to 0, so it's going to be y, e to the log y is going to be y, and this is going to be e to the 0. And hence you get 1. Thus you can say that the limit x goes to 0, x power x is equal to 1. Okay? So this is the way to deal with the... So if I summarize, there are two basic forms, 0 by 0, infinity by infinity. By the way, L'Hopital rule works only on these forms. You have to keep one thing in head, on these forms. But there are other indeterminate form as well, 0 times infinity. If you have such a form, try to convert it into 0 by 0 or infinity by infinity form. Or if you have infinity minus infinity form, for example, try to convert it again into, say 0 by 0 or infinity by infinity form actually. And if you have this infinity power 0, 1 power infinity, or 0 power 0 form, okay, then by taking log you will convert it into such a form always, and then convert such a form into 0 by 0 or infinity by infinity form actually. So that's really is the map actually, and then compute the limit using the L'Hopital rule actually. Okay, so I hope you got some glimpse of it, and you will have many exercises to solve. Thank you very much. So we'll carry on our discussion. Thank you.